by using those tables to organize information. I just wanted to show you another strategy using systems of equations to solve some of those types of problems. So I put a few on here for us. So in 2006, in the 2006 Winter Olympics, the total number of medals won by Germany and the United States was 54. Germany won 4 more medals than the US. How many were won in each country? If I want to use systems of equations for this, I have to be able to write multiple equations. So I have to use variables. I need to define any of my variables. You should remember that from when we made those tables. We had to, put x in the table somewhere or write out what x was so I knew. What am I trying to find in this problem? So I need a variable for each of those. We have 2 countries, so I need 2 variables. You can pick whatever letters you like. I typically didn't use x and y, but it doesn't matter. So x, I'm going to say, is the number won by the US, and y can be the number won by Germany. All right, now we need equations. If I have 2 variables, how many equations am I going to need? 2. You need the same number of equations as you have variables. So we know the total number won by Germany and the United States was 54. So what would I put?
X plus y equals 50.
All right. The second thing I know is Germany won 4 more than the United States. Okay. The United States plus 4 would equal Germany, which was y. Does that make sense? Because Germany won more, so we would have to add them onto the US. All right, and now I have my 2 equations. Would this one be set up to use substitution or elimination? Substitution. We could easily just substitute the second equation into the first. So we would have x plus, substitute x plus 4 for the y, equals 54. Subtract over the 4, divide by 2, and we get 25. So then we need y. We know y is x plus 4, so 25 plus 4 is 29. And then what would I want you to do? Ordered pair, or preferably a sentence, since it's a word problem. So we could say the US won 25 medals. And Germany won 29. You guys have to quit popping things. I hate that sound. Oh, it's awful.
Lucy.
I accidentally stole your pencil. I still have it. If you want it.
Of course you did. What else has not been stolen from you?
Is this one okay? Let's look at this one. So Sarah has $70,000 to invest and requires an overall rate of return of 9%. She can invest in a safe government-insured certificate of deposit, but it only pays 8%. To obtain 9%, she agrees to invest some of her money in non-insured corporate bonds paying 12%. How much should be placed in each investment to achieve her goal? I'm pretty sure I just took this problem from an example we did at the beginning of the year when we set up tables to solve them. But we're going to do this a different way today. What am I trying to find?
How much should be placed in each investment to achieve her goal?
Okay, how much should be placed in each investment? What are my two investments?
The government issues.
Yeah. Government insured certificate of deposit that pays 8% and
No.
the bond's paying 12%. So I'm going to say X would be the amount at 8% and Y could be the amount at 12%. Right, can anybody figure out what one of these equations might be? That's a good question. So if you have $70 and you spend some and you put the rest in the bank, if I spent 20, how much did I put in the bank? 50, because they have to add up to your total, right? So I took it and I put some at 8% and some at 12%. So when I add those together, it should equal $70,000. The amounts. If I put this much money in investment paying 8% and this much money in investment paying 12%, those percents are just telling me which accounts I put them in. Okay, but the overall thing, I invested all 70,000. So X plus Y equals 70,000. Okay, so let's talk about the interest. If you put X amount of dollars in here and it pays 8%, then your interest would be 0.08x. Plus, what would this one be? Okay. Overall, what kind of interest rate am I trying to get? 9%, so it has to equal 0.09 times my total, which was 70,000. Okay. Now, could you go ahead and multiply that 0.09 times 70,000 if you wanted? Yeah, absolutely. You don't have to leave it like that. I'm just trying to show you exactly where this came from. So what is 0.09 times 70,000?
63.
So would this be better for substitution or elimination? Let's do elimination. Let's say I want to eliminate X. So I would take the first one times negative 0.08. So we get 0.04y equals positive 700 divide 17,500. You guys checking my math? Then we need to get X, so you can plug that back in. So I'll just put it in the first one. And then since it's a word problem, we should answer in a sentence. So Sarah invests $52,500 at 8% and $17,500 at 12%. What questions do you guys have? I'm going to start the next problem with you, but then I'm going to have you finish it on your own. So it tells us that Linda won $200,000 in a state lottery. She first paid income tax of 30% on the winnings. Of the rest, she invested some at 1.5% and some at 4%, earning $4,350 interest per year. How much did she invest at each rate? I'm not sure why I have all these random question marks here. Okay. What's the one thing in this problem that we didn't have in the last one? Tax. Did she ever see all 200,000? No. So how do I figure out how much money we're actually dealing with? So a couple ways of doing that. If you just multiply by 0.3, you get 60,000. That's the amount of tax she paid. So to figure out how much money she actually has, you have to subtract that from the 200,000. So we only actually have $140,000 to work with. Why don't you guys try to write the equations from here? Define your variables. So what you do, X the amount at 1.5% and Y the amount at 4%. So what was the first equation? Second one has to do with the interest. So if it's 1.5%, that would be 0.015x. 4% for the y, so plus 0.04y equals, how much interest did she get? So now we are ready to do substitution or elimination. Probably a little bit easier to do the elimination here. So we're going to take the first one times negative 0.015. Um, 140 times that. We have 2,100, is that right? And what do you get for y? And we know that x plus y equals 140,000, so if we plug that in, x is 50,000. So Linda invested 50,000 at 1.5% and 90,000 at 4%. that okay? Do we need more of these? I've got more ready if you guys want them, if you know what we're doing. I don't want to keep doing something if you're ready to move on. Where are we at?
We're good.
Good? Does everybody agree with that? Make sure on these word problems you're defining your variables and then answering the sentence. Let's flip over to the back. The last thing I wanted to do today was, yesterday we focused on substitution and elimination, but everything only had 2 equations. And we could have a lot more than 2. The most we're going to do is 3, so I wanted to do a few examples with 3 variables that we're solving for. Essentially, it's the same strategy. It'll probably be a little bit easier to do elimination than it will be to do substitution. What we're going to do is pick a variable and we're going to try to eliminate it out of everything. So what do you want to get rid of? X. Okay.
Good choice.
We're going to take 2 equations at a time and get rid of X. So if I took the first 2 equations, if I wanted to eliminate X, what would we have to do? The top one times -4. Okay, so I'm going to add this together. I have -7y plus 6c equals 20. So I haven't gotten an answer yet, but we're on the right track. We eliminated X that time. We have not used the third equation yet. So now I have to take the third equation, one of the other 2, and eliminate X again. So which one do you want to put it with? First one? So what would you have to do this time? Okay, take the first one times -2. So when I put those together, we have -4y minus c equals 7. Now, I am going to put these 2 equations. You notice I have 2 equations and they both have 2 variables. We need to put those together and eliminate something. What do you want to eliminate? Z. So we could take this one times 6. So 31y equals 62. Divided by -31 and y is -2. Once we have a solution, what are we going to do? Yeah, plug it in. So I'm going to plug this in to one of these equations. Let's just put it in right here. So -4 times y, which is -2, minus c equals 7. Get z to be 1. So now I have y and z. We have to go back to one of the originals and get x. So if I just go with the first one, so it would be x plus y, so -2, minus z, so -1, equals -1. So we get x to be 2. When we write, this will be, we have 3 numbers, just go alphabetical order, so x, y, z. So 2, -2, 1. Alright, so adding that third equation didn't change how we solved it, but it certainly made a lot more work. And we can probably imagine if I had 4 or 5 equations, how much longer that would be. So this will be the most that I'm going to give you, is 3 at a time. Are there questions on that one? If you don't mind, I would like to go ahead and do the last example and then I'll stop for today. Give you guys time. I don't know why that's partially cut off. Okay. What do you notice about this third equation?
There's no Z.
There's no Z, so I like that. Let's then take the first two and try to eliminate the Z. Do we have to do anything? No, we can just add those together. So now I need to put these together and eliminate something. So if we multiply by -1, we have -3x minus 2y equals -3. And positive 3x plus 2y equals 0. When we add those together, what happens? Good. 0 equals -3, which we know can't happen. So we say no solution, inconsistent. So there is a handout posted on Classroom, and you've got quite a bit of time right now, so you can ask questions if you get stuck. Tomorrow you will need your textbooks, so make sure you bring those.
I think I do.
Where?
No, where's that later? I go that way anyway, so it's so crazy.
Yeah.